I'm Kent Blatsit. I'm team lead for the HPC Platforms Group at BP. And we had the fun experience of upgrading our scheduling system after over 20 years using SGE. We moved to Slurm. And of course, we had the questions, why do we need to move? We've been doing this for 20 years. There's nothing wrong. But we were at a good changing time where we were at the end of a long support agreement, and the vendor was not real interested in continuing with a node-based licensing agreement. They're wanting to move to core-based, just like Oracle and all the other people. So that was going to be a significant uplift in cost. And also, if we did any work in the cloud, which our management would love us to do, or at least they do until we try it and show them a cost estimate, that licensing was not going to work in the cloud. They insisted on core-based charges there. Since BP's users it's mostly for research, they have all kinds of scripts all over the place, things they've built up over 20 plus years, and they were really concerned about having to go change all of those. And how many of the features do people really use? It's not too many. So we looked around on the market several times and came to the conclusion that Slurm was the cheapest and most supported scheduling system out there that people would use, has decent support in the community. You can get commercial support. It's also not the cheapest that you can find. We've chosen to start off with self-support, and so far it's been okay. You know, as when we're changing from SGE to Slurm, us going through, reading the man pages and everything, there are just so many options. It's incredible. But if you look at the SGE man pages, they've got tons of options that we never use. So is it any different? Not really. We know through third-party application integration that Slurm is better supported in the market. So we felt that was going to be a bit of a reduction overall at the end of the day by moving to Slurm. So eat your own dog food, set it up for yourself, and doing sysadmin type work. And we know our users pretty well. So start doing some things like you know the users do. Then go out and identify your big application families. Like we've got our big internal seismic applications, and if you get one of those working, you've got them all. It's not a big change. But then you've got your reservoir people that have a different application that has to be tuned and tweaked. And then you've got your CFD users, and then you've got a long tail of small applications that are used by a very small number of people. And then have you built other tools that also use your scheduler? We used our scheduler to do a lot of monitoring of systems. We had built tools for users to find out what resources were available for them based on their project and their user ID and clusters that they might typically want to use. We also did job monitoring and analysis through the scheduler. So we had to figure out how to do that with something else like Slurm. And also be nice to your carbon-based scheduler. We have a person who controlled what SGE ran. He had a much better idea than you could ever program into a scheduler for what was important to the business. So he would tweak SGE to fulfill those needs. A lot of that would include holding jobs out of a queue to let a big project get enough room to come in. In most cases, small jobs will go in and just take over a cluster, and it'll be tough unless you got an outage like Tommy talked about and doing Texas scale jobs. So take a look at all that, the different applications you've got, and the users and your resources, and just start making schedules, and understand you'll have to be flexible, but don't back off too much. And you've got to avoid the pitchforks that are going to be out there if something screws up. But you know some of your more challenging users, and just go work with them. Some of them will be easier to work with than others. You typically know who those are anyway, so just go talk to them and offer to help. And communicate early and often. Through this process, we did a lot of communication to different groups, a lot more than we ever do on other upgrades, and really listen to what they're complaining about. We made some cheat sheets on just very simple, okay, here's the SGE option, here's the Slurm option. And so they could go through and look at their own scripts and see how easy it was going to be for the vast majority of things. One of our people made a website that lets you copy and paste your submit script in from SGE, and it would do the conversion right on the screen. And so a lot of people were able to use that. There are sometimes features that we didn't really realize were being used a lot by certain groups, and we had to make a quick change to some of the tools with Slurm to let that be handled. In this case, it was a group that used job dependencies based on job names instead of job IDs, which was something Slurm did not handle by default. And Jonathan figured out how to do that pretty easily. We did a lot of drop-in sessions so people could come in with their specific scripting and figure out how to get it done. We ended up with a sysadmin and a developer on all those calls because different people would understand what was going on and why. One thing we were also doing was upgrading from CentOS 7 to Rocky 8 at the same time. So we had more resources available on Rocky 8 than on CentOS 7, and we intentionally converted clusters and racks over to the new OS and said, well, if you need more resources, they're available over here, and we'll help you fix your scripts to make it work. So there's a little bit of carrot and a little bit of stick. We also kept both queuing systems running at the same time, just disabled machines in one queuing system and enabled them in the other. And we've had a couple times where we had to move a few racks back and forth as different projects were coming through. That also told us when we needed to move more resources to Slurm. We kept good track of the utilization during this transition period. The transition was about 4 to 6 weeks, and yeah, it was okay. It wasn't too bad, but we had discussions every week on, okay, what projects do we see coming up that still need CentOS 7, and which ones can go over, and we had to slow down a few things and speed up others. At the end, we had one application that would not run on Rocky 8, and so we had to stick around with that one for another month or so. But it was, what was it, 30 nodes? A rack, maybe? It was one rack. So out of 75 racks, that's not a big deal. Oh, that's punishment. I said be firm. And we're still learning. Anybody that's used Slurm would probably agree that it does not have a decent GUI like SGE had, which had not been supported in over 10 years, so we weren't losing a whole lot. You can get all the same information out of any scheduler. They've got to have the same stuff in there somehow. You just got to figure out how to do it. One thing we had a little bit of concern about, and we're still working through issues on, is with SGE there was something called a parallel environment, which could span queues. That's not really something that Slurm is able to do with partitions, and so we've had to work with reservations and quality of service settings as kind of a workaround, and so far that seems to be pretty much okay. To me, it seems like we're having to restart the Slurm scheduler too frequently. Things that just updated in SGE, we have to restart the controller. It's just a blip, but it seems like it shouldn't have to do that. There are a few things that you need to think about. Some defaults. One of the ones we've run into is, do you do default to oversubscribe or exclusively allocate nodes to jobs? We chose to do exclusive use of machines as you allocate jobs. People can override it by saying oversubscribe, but you've got to pick a default. And so that's what we chose, and Jonathan, I think, is maybe regretting that. But we'll see how that goes. There are a few things that could be that way, but not too many. So it's the end of the world as we know it, but I think it worked out okay. And it was definitely not just me doing this. This was about 5 other people in this room and a few others that are still back at the office. We depended a lot on the patience of our carbon-based scheduler, David Lewis. He's not known as being the most interested in change. Keith would know that as a slight understatement. But I think we even got him reasonably comfortable with Slurm. We have had to go out and make some tools for him to emulate what he had in SGE. There are a number of tools for doing accounting, and we don't do billing, but we keep track of the accounting so we have an idea of utilization for the questions that come up about, well, how busy is your staff? And just giving an overall number is very helpful. And that's about it. And our users were pretty good in the end. So that was good. That's it.
found your presentation really insightful. I was wondering about the exclusive flag. So in our cluster, we have a couple of GPUs. So if you have the exclusive flag on, you can't share the GPUs, right? So even though if a job is just leveraging one GPU, you're blocking the whole node, which has like 4 GPUs or something like that.
That's why
That's same for the core. That goes same for the cores as well, right? If a job can only take advantage of couple of cores, you're going to block the whole node for like that job, and it wouldn't be really efficient,
that's why you use the oversubscribe.
right?
And then you can, what we do, we use C groups to say, you know, if you request 2 CPUs or 2 GPUs, that's all you're going to get is that fraction of the machine. If you've got 96 cores in the machine and you request 48, then you're going to get half of the cores, half of any GPUs, half of any NVMe disk drives. It's just a fraction of the machine.
Right. Okay. Thank you.
Okay.
And it'll show up in the -A report for somebody wasting resources.
Like somebody else mentioned, I think it was you, these resources are so expensive, we need to watch, because a lot of people are trying AI, and they don't necessarily realize how much or how little of the GPU they're actually using. So some of this will be to identify users that aren't being efficient with the machines and hook them up with a developer that may be able to tell them either you really don't need to be on the GPU, or here's how to use it better.
I apologize in advance for having a comment and not a question.
That's
But you mentioned that Slurm doesn't let you submit jobs to like across multiple partitions. Something that we've done in the past is, so Slurm partitions don't have to be disjoint. So you can have a partition that is the sum or a union or even just an intersection of 2. And so then if you want to submit into a larger subset of your cluster than any one of your existing partitions, you can just define a pool for that.
Okay.
So Tim introduced me. I work at Oak Ridge National Lab, and the team I'm on, we work on providing system monitoring and operational data services to the Oak Ridge Leadership Computing Facility and the National Center for Computational Sciences. So I'll give you a quick introduction and context. So the area that we're working in is operational data analytics, which is a framework for HPC data analytics that encompasses the monitoring, archiving, and analysis of near real-time performance data. So providing actionable information for multiple operational uses. So ODA data includes data that you're all probably very familiar with: telemetry, logs, metrics, sensor data, and any monitoring information. So to make use of this data, we have to extract the information that is relevant to us. So identifying the information, then putting work into transforming the data, normalizing vendor-specific naming conventions or units of measure, and then monitoring those data pipelines and the data quality to prevent missing or incorrect data. Once you have good data, then you can create dashboards, which provide diagnostic information across the ODA pillars of building infrastructure, system hardware, system software, and applications. So these dashboards provide, they're important for operational data in Linux because they let us visualize hardware and application performance to identify and eliminate performance bottlenecks, as well as identify issues and eliminate inefficiencies that may come up in hardware. So the motivation for this work arose from 2 sources. So internally at OLCF, providing our operations personnel and users with the information about their jobs or the machine itself that they needed. So a lot of the data is centered on temperature management, power attribution, and node and job level event information synthesis. And secondly, we work in a larger ODA community that identified a need for some standardization in HPC monitoring. So there's differences in data format, density, and component granularity between vendors and solutions, and it makes it difficult to just use a monitoring dashboard or solution from an earlier system or from someone else's site and plug in your own data and go when you have a new system coming into production. So our goals with this project are to establish a standard dashboard for telemetry data for use at multiple HPC sites, make this dashboard open source so HPC sites and others in the ODA community can use it and improve upon it, reduce the amount of effort and time required for sites to understand and use data effectively, and provide it as a resource or kind of roadmap to collaborate with vendors in developing telemetry solutions. Really quick, this is our analytics and monitoring architecture at OLCF or at ORNL. So we have on the far left all the different data, data from different sensors or file systems from our systems. That all gets fed through a Kafka stream into Druid or Elasticsearch. And then data is then piped from those data sources into Grafana. So our input data for the dashboard is Slurm and HPE's HPCM data management system. So we did write our own custom Slurm scrapers to collect job metrics, and then for HPCM, we have Kafka Connect set up, and it produced telemetry data directly to our Kafka system service. There we go. We did have to add the host name of each node in the HPCM data so that we can merge it with the Slurm data down the line. That was important so we could build the dashboards we wanted. And very quickly, I'm sure most of you are familiar with Grafana, but if not, it's an open source observability platform. So dashboards in Grafana are backed by a JSON configuration file, and that file includes dashboard properties, metadata, and template variables, as well as data source information. The dashboards are also broken up into new collapsible rows, and in each row are all of the visualization panels. So this is a view of our node info dashboard row. So each of those are different panels. And metrics here are for a selected node. So you can select your node that you're interested in and get all the information you want to look at. This is our job info dashboard panel. Metrics are displayed for a selected job. So we have the job ID available, and either eventually users or administration staff can look up a job ID and get all the information that they want about it. We also have a batch script option, but we have not added that into our dashboard model yet. It is in our production dashboard, but not in this project. This is our live system stats panel, which contains aggregate statistics about the total number of jobs and nodes in the system and recent trends in the scheduler workload. This panel uses HPE's cluster view plugin. So each of the colored squares represents an individual node and is grouped by cabinet location and placement within the cabinet. So the green nodes are running, red are not running, and blue, there's a small bit up there on the right top corner, those are idle. And then another one using cluster view plugin, this is the job layout panel. Highlighted nodes are those in use by the selected job, so you can select a job by job ID, and additional metrics such as CPU and GPU temperatures, power consumption, and CPU load can be toggled on and off in the panel. All right, so real quick, I'm going to move quickly through our script because that's a little less interesting than the dashboards, but So we have, our workflow is pretty straightforward. We have a site-specific configuration file, a generic Elasticsearch site-specific file, and the output is a site-specific dashboard JSON. We're working on a wrapper script so that you can just automate the upload of the new JSON model to Grafana rather than having to copy and paste your JSON. So this is a sample of the kind of the end product, the site-specific dashboard JSON model. This is the templating section, which contains an array of variables with their values along with metadata. So this shows information about one of the Elasticsearch data sources that's used in the dashboard. So important piece of information here, the main part of the dashboard that we're working with is the data source. So we're leaving a lot of the formatting and that sort of thing, and kind of pulling out data source information and plugging in new data source information. So these highlighted portions, as I mentioned, are the portions of the JSON that the script targets. So this is the site-specific configuration file. So anyone who uses the script populates this with their own site's specific data source information. So the highlighted portion with text and regex, which are the site DB node info and regex and string sections. Those will then be used down the line in the script to populate the final JSON model. You'll also see highlighted the node information row. Users can select all or only some of the rows depending on the data you have or the data you're interested in visualizing. So in this case, you see node information is the one we're going to be looking into. This is the Elasticsearch generic file. So this sample, we refer to it as a conversion file. And the script reads this file into a Python dictionary. And it is used for removing, transforming, and adding the normalized site-specific information from the site-specific config that I just showed you into correct dashboard fields for the new site-specific JSON model. This is a snippet of the beginning of the row in a generic dashboard config. So this file is basically, it's like the final one you would upload to Grafana, but we've stripped out all of the specific site-specific data source information. So it's basically like a skeleton of your JSON. Again, here's the generic dashboard config. And this shows the node info section, which we will then populate with more information. So then back to the site-specific dashboard JSON model. So that node info key was used by the script to then fill along with other keys. It's a bunch of dictionaries. If you're curious about how it all works specifically, we can definitely talk to you about it. But we basically transformed that generic model into this specific model with the data source information from our site added to it. To use this, we still have it, it's still behind ORNL GitLab, so you'll have to create an account to access it. It's not fully open source yet, but if you reach out to us, we'll help you with getting access to it. It's still a work in progress, so we're constantly changing things, adding things, and we're working with other DOE labs and vendors to add more features, test different data sources, and so forth. So that kind of leads into future work. We're working on a standardized HPC telemetry schema. We are going to implement and test methods at other HPC sites, improve the usability with documentation, scripting, API access, and broader backend database support. So one of the databases we're going to be looking at next is Victoria Metrics and Prometheus, similar. but we'd like to get that support added in there because a lot of people use that as well. And that is it. Thank you so much for your time and for sticking it out to the end. This is a contact for the analytics and monitoring team, and please let us know if you're interested in helping work on the dashboard, use a dashboard. Yeah, thank you.
It's a quick question.
Yep.
With the visualization that you're doing with your dashboards, are you leveraging any alerting along with that, or is that possibly why you're looking into Prometheus?
We're not currently using alerting. That's definitely something that we could add down the line, but right now it's used more of a, we just check, and then our user assistance group uses it mainly for if there's issues with jobs or that sort of thing.
Thanks.
Mm-hmm. Yeah. So we've got, how many of us are there? There's 6 of us on our team. But let's see, we've got, we have like 80 Elasticsearch pods. And then we've got, I've lost count of the Druid. Tim, you might need to help me with the hardware numbers. Mm-hmm.
16 with a petabyte of storage each. They also have NVMe drives that we're using for hot, but it's a whole lot smaller. And then we have the Kafka bus is only 6 nodes that are working, and they aren't actually, that's the smallest thing, and it's pretty simple. And then the Druid nodes, well, so we archive into a Minio. Like it's a pretty ornate architecture. Minio is 4 nodes, and Druid is 4 nodes also.
Mm-hmm.
So
Oh, yeah.
overall, how many is that? 6 plus 4 plus 4 plus 16. That's 30. There we go.
And we use Kubernetes, so we're sharing applications across hardware. I mean, all of our data we're ingesting 4 terabytes a day, roughly. This specifically, I don't have a number of how much like the data is for this dashboard because it's not everything. Sorry, I'm not holding back. Yeah. Yeah, I mean a large portion of that is like storage and file system data. But yeah, it's a pretty large amount. Mm-hmm.
Question about the Slurm scraper.
Mm-hmm.
Where does that get ingested, or what's the? Literally, it's just a custom binary you guys made or script that.
Oh, it's a Python script. Yeah, custom Python script.
What is it exporting it as? Is it like a Prometheus exporter or something different, or?
No. So we have pods set up for that data, so it gets exported through that. Well, I'm trying. Yes.
Is that open source or not? Really?
No, it's yeah. Yeah, Leah Huck did a lot of work on writing the Slurm scraper.
Yeah, the only reason I ask is because there's no like official Slurm scraper anywhere out in the wild, right?
Yeah.
What's that? Is that the one that hasn't been updated in 7 years or something, or no? Okay. Fairly recent, okay.